morning.
How is everyone today?
Tired.
Tired.
Yeah.
I got some sleep, so I'm less tired.
Yeah, we did our physics midterm on Monday. The teacher offered us the chance to get some points back for anything that we missed.
Oh, cool.
So I've been racking the brain trying to get some of those done.
Awesome. Which teacher is that?
Nicoletta Sharp.
Okay, cool.
Yeah. That would get 15 points on the quiz, so if I can get 15 points back, I can be 100%, which would be really awesome.
Awesome. Yeah, physics is challenging, but it's definitely doable.
I love it and hate it at the same time.
That was my experience.
Yeah, it's very interesting, but you know, you're in college, you know, it's on your hand, it's one of those things they expect you to know it and you believe it, and sometimes it just doesn't work out that way. Sometimes you gotta look it up.
All right.
There's a lot of good resources though now.
Oh yeah.
Well, Google, you know, a lot of websites that give you or help you with like formulas and stuff. If you're trying to find a specific formula and explain it to you. So it's just like having another teacher explain it, you know, it's kind of nice.
Right. The only downside to that, at least with programming courses, but I'm guessing maybe with physics too, sometimes there's too much information out there. And there's lots of people who are trying to be helpful, but they can tell you like all kinds of things that sort of complicate the story.
Yeah, I haven't really found it very useful for programming, just because, like you said, there's so many different ways to do it, and you're seeing how this person finds it, you know? But I think physics is more like, there's only one way to do it. You know, this is the equation.
Okay.
This is what you're looking for, so it is helpful for me, at least, in that way, but programming, I really do this stuff anymore, because there's no point. Just things that too much information, and a lot of times it's like,
Right.
from this library, and we're not supposed to take from that library, we're supposed to do it on our own. So it's just not, it doesn't make any sense.
Right. All right, well, good luck to everybody who has their physics coming up Monday. So our midterm is tomorrow, and again, it's during class time. So for this class, the midterm is from 11 o'clock to 11:50. And Canvas will open up at 11. And there was a typo on Canvas. Canvas was saying that the exam opened at 10 and closed at 10:50, but that was just a typo. So the exam is during class time. Opens at 11 tomorrow, and closes at 11:50 unless you have an extended time allowance. Canvas will not stop accepting uploads. It doesn't close the assignment or anything like that. If you have an extended time allowance and you upload after 11:50, it will show you that it's late, right? But I'll ignore that. I know what your time allowance is, and as long as it's turned in within that extended time, it counts as on time. So just ignore, you know, if Canvas says it's late, but you know that it shouldn't be late, don't worry about it, right? And there's no warning from Canvas that, you know, this is due in 5 minutes or anything like that. You got to keep track of the time. And I'll try to mention in Zoom, you know, when you got a few minutes left to wrap up.
And I know you said you have to upload, obviously, our code and stuff. So is it going to be basically the format of like a couple different kind of ODP style questions, or
It will. It'll mostly be like ODP style questions. So there's some Bash, there's some C. It's all programming questions. There's a few questions where you're writing complete programs. There's a few where you're writing, you know, maybe a function. There's a few where you might be writing 1 or 2 lines of code. And there's different point values for different questions. So my suggestion is, you know, glance over the exam, and then look at the point values and decide what you want to start with. And, you know, obviously if there's a 10-point question and you have no idea how to do it, you probably don't want to start with that one. because if you do nothing on it, it's only 10 points. But if it's a 25-point question, right, you probably want to spend some time on that. So, but if it's a 10-point question, you feel like you can do it in 2 minutes, go ahead and do that, get done with it, right? So do a little bit of planning, right? Eyeball the whole thing, decide how you want to go about it, and then just start writing code. So you can use a plain text editor, you can use Notepad, Notepad++, VI, Nano, whatever you choose. But don't use something that corrects your syntax for you or writes C code for you. Don't compile your code, don't run your code to test it, nothing like that, right? And then you want to save your code as a PDF file. So if you're using Notepad, under Windows you should be able to just say, print to a PDF and get it outputted like that. But hopefully everybody has done this at this point and has figured out how they're going to write their code, type it in, and turn it into a PDF. And then that PDF gets uploaded. There's no limit on the number of uploads, so you can upload as you go. Or if you're getting close, if it's like 11:40 and you're going to work on this problem that you're not sure how to do, right? Go ahead and upload what you got at that point. And then take, the last 9.5 minutes and try to get some extra points. But, do something that makes sense so that if you lose track of time, you only got 15 seconds, that's not the first time that you're going to try to make a PDF and so on. Canvas does not lock out your uploads, but if you upload late, it's 10 points per minute late. So if you upload 10 minutes late, that's a 0. But the upside of that is if you upload a few seconds late, it's not a 0 yet, it's a 90. What else can I tell you about that?
I got a question.
Yeah.
So we're not going to answer the question on the canvas, right? We just need to download the exam and finish the exam on the PDF and submit it.
Exactly. Yeah, so Canvas. Go ahead.
So we just need to download the exam as PDF and finish it, right?
Download the exam as a PDF, write up your answers, save your answers as a PDF, upload that.
Okay, cool.
Yep.
Thank you.
If I want to write it in Vim, is it okay to just take a screenshot and then convert screenshot to PDF and upload that? I mean, or does it have to be like an original saved to?
I would rather not have a screenshot, only because if there's any difficulty in reading it, I'm not gonna have the time to try to decipher blurry characters and so on.
Okay, I'll probably just use Notepad then. I haven't had to do that directly from any sort of program.
Well, you can use Vim and you can just copy and paste from there into Notepad if you want.
Yeah.
Right. So depending on how your environment is set up, usually you can just select the text, and that copies it, and then just Control V it into Notepad.
Okay. Thank you.
Mm-hmm.
So
All right.
I've been writing so much in C, I gotta refamiliarize myself in Bash now.
Yeah, definitely go back and refresh yourself on Bash. That's been a while. Let's see. Or if you decide to publish the repo, you could download the text file from there. That's true. All right, go ahead and send me an attendance note, please. Let me know who's here. And yeah, Stack Overflow is always good for an ego bruising, because I think it's almost impossible to put anything on there without people jumping up and down all over it. And it's got its share of trolls who will post things just to get people unhappy.
That's the nature of having multiple right ways to do something.
Mm-hmm. Exactly. All right, thank you for the ping. Yep. Yeah, if you're in Linux, there's ways you can convert text files to PDF. So A2PS is one way to do that, but you can.
If you have a virtual computer, it's pretty much a separate machine, right? You can't copy it on there and paste it on another one.
You can. You have to set it up.
Okay.
And there's a video on the YouTube channel that shows you how to set up both a shared folder and a shared clipboard. And the shared clipboard is really convenient because then you can
Yeah.
copy something in your VirtualBox window and paste it outside and so on.
Okay. I'll have to look at that.
Okay. Yeah. Yeah, Stack Overflow is an interesting survey. Are there any programs installed to the NGRS server? So I just did a man-k PDF, and these are different things that are available, and you could play around with these. Although it's a little late in the game to be brushing this off, but you could try it. I don't know if A2PS is what it's actually called. But definitely, play around with this because any of these commands in Linux, it's possible you might, clobber your text file while you're doing this, and you got to download from the Linux server to be able to upload to Canvas and so on. So, unless you've done this before or you tested it far enough ahead of time, right? I wouldn't mess with anything too funky. You can always, just go into Notepad, write your stuff, and say, print to a PDF file, and go with that. But for down the road, you can play around with A2PS, and that can work sometimes. Yeah, either of those sound good. All right, I think that's all I have to say on the midterm. Any other questions or concerns? All right, let's talk about PA3. So PA3 is posted. It's another C program. This time it's a C program to play the game of high-low. So high-low is, another one of these games that you've probably played before. The basic setup is one person thinks of a number, the other person tries to guess it. And if you think of a number between 0 and 100, it can be tricky to try to guess what that number is without having to make, a lot of guesses. So is it 3, is it 17, is it 5, is it 2? If you just kind of make random guesses, it could take you, 100 guesses before you happen to hit their number. So you're going to write a program that not only can guess the number that you're thinking of, but can do it very efficiently. And so we're going to talk about the algorithm that's used for this, and we're going to talk about a lot of details about what your program has to do and how it has to do it. But let's start off by just looking at a sample executable. So this description is 4 pages. It should have all the information you need, but let's go through this. So first of all, on the Linux server, there's a sample executable under /temp called PA3, which I think I need to make readable by the world. Nope, that's executable. Okay, so if you just run this with no command line arguments, it says, welcome to my high-low game. You'll be asked to think of a number, and I will try to think of it. Should say I will try to guess it. When I tell you my guess, please respond with H, L, or C to indicate whether my guess is too high, low, or correct. Alright, so that's just, an intro to the game. And then I wanted to say something like, please think of a number between 0 and 100. Right? And if I just run this with no arguments, the game is between 0 and 100. And then it says, hit enter when you're ready. So it's waiting for me to think of a number. Alright, so I need a volunteer to think of a number between 0 and 100.
73.
But don't tell us what it is. Alright, you got another number?
Yeah.
Alright, cool. So, got a number in mind, you go ahead and hit enter. And it says, I will guess your number in at most 7 guesses. So first guess is 50. So is 50 too high, too low, or correct?
Too low.
Alright. Guess number 2 is 75. Is that high, low, or correct?
Too high.
Alright, how about 62?
Too low.
68.
That's correct.
Wow, cool. Alright, so it only took 4 guesses to think of your number.
So does it always start at 50? Just kind of cut everything in half?
If you're playing between 0 and 100, you want to start at 50. And we'll break that algorithm down in a minute and see why that's a good way to start. If one can't read the file, can the person still detect if the file is there? In general, in Unix, do you mean? It gets into the permissions on directories versus files. If you can read the directory, you can see what files are in there, even though you might not be able to actually read the file. But directories are just another kind of file, and they have permission bits also. Alright, so one thing we can do is we just say, name of the program, and it plays from 0 to 100. We can also put in a number that we want to play from 0 up to that number. So if you want to play, think of my number between 0 and 1 billion, I can do this. Temp PA3, and I can put in 1 billion, and it'll say, okay, think of number between 0 and 1 billion. And I don't know. Let's think of 224, because that's an easy number to remember. Because that's our class.
The sorting method that you always get the phone book example for.
Yeah.
Is it root in, like O root in or something?
Mm-hmm, exactly. Alright, so I'm going to think of the number 224. So half a billion is high, that's high. And it said it's gonna take at most 30 guesses, right? So all of these are gonna be high. $237 is high, that's low, that's low, that's low, that's low, that's high, that's high, that's low. 224, last guess number 30. Oh, but I lied. It should have been correct. Alright. So this is an efficient algorithm, right? You've got 1 billion possible numbers you could have thought of, and it got it in 30 guesses. Alright, so that's the second thing you can do, is you can run this with a command line argument which says play from 0 to that, or you can play with a range of numbers. So if you want to pick a number from 1,000 to 5,000, you can do this. Name of your game, 1,000, 5,000, and it says, hey, I'll think of a number between 1,000 and 5,000, and I'll guess it. Alright, and those are the only 3 options, either no arguments, 1 argument, or 2 arguments. So if you run this with more than 2 arguments, that's an error. Give them a message and exit. If you run this with an argument that's not an integer, that's an error. Give them a message and exit. If you run it, with something like haha, that's an error. If you do this, that's an error. If you use a range, but the first number is not smaller than the second number, that's an error. Right? So the command line parsing that we've been doing in programming assignments and ODPs, same idea here, right? Except in this case, you're allowed to have 0, 1, or 2 arguments. And we do different things in each of those cases. All right. Once the game is playing, think of a number between 0 and 100. I don't care if you hit extra stuff here. It's just giving you a chance to think before you start playing. It wants an H, an L, or a C. This has got to be an H, an L, or a C. If it's not, say, hey, enter H, L, or C. Insist that they type in exactly one of those. If they say hi, that's not a valid answer. If they say uppercase H, that's not a valid answer. It's got to be H, L, or C. So they can say hi, they can say low, they can say that's correct. There you go. All right. Any questions on the gameplay at that level before we go and we look at the detailed write-up? All right. So this is a 4-pager that should cover everything you need to know. But we'll see how well I did. No command line arguments, you're playing from 0 to 100. So if you just do this, your low is 0, your high is 100. All right, and the details of this assignment are critical, okay? It's possible to write a program that plays high-low beautifully, and you only get 10 out of 100 points on PA3. So you got to follow the requirements in this write-up. And there's a grading rubric at the end that you can use to figure out what grade you're going to get before you even turn it in.
You get marked down for going above and beyond. Like, it had the command lines where the first one was higher than the second one. You can, like, parse that to put it in the correct order if you wanted, and that would get you 0 points on that.
Yeah, so don't do that if it changes the behavior. If you wanted to have, you know, a dash fancy switch that you could put on that enables all these other things, that's fine. Or if you want to say, you know, sorry, that first number is too large, how about switching them around next time, you know, or something like that, that's fine. But yeah, pretty much stick to the letter of this. And this one, even though I grade it by hand, I'll probably write some scripts to exercise your code, right? To play it in different scenarios and get it started, and then I'll play through the game. But I'll be expecting, you know, very specific behavior. So try to stick to this. All right, so running the program, your executable is going to be called main, very imaginative name. It's got to be called main, M-A-I-N. And there's the 3 ways you can run it. No command line arguments, 1 argument, or 2 arguments. There's some examples of each of these 3, similar to what we just went through. And if any of these integers are invalid, print an error message and exit. All right, game starts by asking you to think of a number between, you know, whatever the low and high range are, and waits for you to hit enter. And so if you say 0 to 200, say think of a number between 0 and 200, hit enter when ready. All right. I don't care if you modify the wording of this a little, as long as I can see the low range, the high range, I'm being told to think of something in between those, and it's waiting for me to hit enter before it starts. You can definitely reuse parts of PA2 in this, and there is no catch. That's your life as a programmer, right? Code reuse is huge. And unless I'm doing totally random lectures that have no relation to each other, you probably should be starting to notice that you can reuse code from other assignments. That's a good thing, right? We don't want to have to reinvent the wheel every time that we want to write a piece of code. So if you see things from PA2 that you can use in here, that's fantastic, right? That means you're seeing the connections as we move from one topic to another, and how some things are paralleling, and that's great, right? That's just going to get more and more. Yeah, we're very eco-friendly, and hopefully lazy, because laziness inspires code reuse. All right.
It's going to be a lot
Yeah, so it's a more complex program, but doesn't have to be terribly more complex. It's still going to be, one main gameplay loop. There's going to be some setup in the beginning. There's going to be a main loop where you're getting some information from the user along the way, and then you exit under certain conditions. Alright, so I want you to say what your guess number is, and then tell me what the guess is. And then wait for the user to say, that guess is high, low, or correct. Keep going until the person says it's correct, and then the game's over. Alright, it's possible to cheat. It's possible to change your number partway through. So if I run this, let's say I'm thinking of the number 60. Alright, so 50 is low, 75 is high, 62 is high, 56 is low, 59 is low. I don't want to lose the game, so I'm going to say, no, it's not 60. 60 is too low. Okay, it's going to ask 61. I don't want to lose the game. I'm going to say 61 is too low. It knows that something went wrong. Right? It knows this because previously I told it 62 was high, and now I just told it 61 is low. Well, there's nothing in between 61 and 62, so I must be cheating. So you want your program to be able to detect that. And if it detects that, you can call the user out and just exit. Alright, we'll come back and talk about the algorithm in a minute, and that will tell us how to detect cheating. And we'll also talk about how to predict the required number of guesses. So there's a sample executable, that's what we've been playing with, so you can use that to see what your code should do in different situations. And then there's all these other program requirements. And these are all worth points. And you don't need to do these things to make a high-low game, but you need to do these things to get a good grade on PA3. So the first piece of this is we're going to break your program into pieces. And these different pieces are going to go into different files, and they're going to get put together. And they've got to look exactly like this. So you need a file named intro.c, and that should contain a function called intro. Intro takes no arguments, returns no arguments, and that just prints the basic hello message. Alright? Not a big deal, but it's an easy way to sort of, get our feet wet with putting things into functions. So we don't pass anything to it, it doesn't send anything back. It just prints out, hello, welcome to my game, blah, blah, blah. Alright? And then another file. Go ahead.
So when you're calling that, you just put that in with empty parentheses.
Yeah, you just say intro, paren, semicolon, and that'll call it.
What is the typical behavior when passing something to a function that expects no input?
If it expects no input and you pass something to it, you should at least get a warning from the compiler saying, parameter list mismatch or something like that. Will it cause any harm? Probably not. The argument will be there, it'll go into an area of memory called the stack, and if nothing picks it up, it's probably not a problem. But modern languages will yell at you and call you names and stuff like that. C will just let you do it.
So when, on the other hand, like I was doing the ODP last night, and part of the ODP said, if there's an error, print the error and exit the program. And so I just put in, I put in an empty return, but my program, of course, just says, hey, I'm expecting a return value, but I didn't give it one because I didn't want anything to print to the screen.
Mm-hmm.
So then the compiler says, oh, hey, you're returning with no return value, but you declared one. Is that a big deal? I don't like seeing errors in my compiler messages. Is there a way that we should be returning when we intend to return nothing? What's the right way to do that so we don't throw errors?
So if you're in a function that doesn't need to return anything, you can declare the function's return to be void. So you could say void function parentheses blah blah, or void main parentheses blah blah. And if you're in a function that's declared to return a void, you can just say return, and everyone will be happy. if you're in a function that's supposed to return an integer, and you just say return, then anything that's using the return value is getting basically a random number. And so if you don't have a particular integer you want to return for some reason, you can just return 0, for example, just to keep the compiler happy. But probably if you have a function that's declared to return, say, an int, you probably want to return, you know, whatever the appropriate integer would be for the case you're in. But beyond that, it kind of depends on the specifics of the program you're writing and how you're using the function.
So like in the ODP, like you're only supposed to, like, if there's an error, return, or, you know, print out the word ERR and then exit the program. Is there another way to exit the program without using the return?
You can use exit, but if you just make your main program to be void main, you can just say return, and that exits.
Right, but in that with the ODP, we did want an actual return. We wanted to return the sum of the two numbers. So
no, I wanted it to print the sum. I don't think the ODP said anything about the return value from main.
Oh, you're right. It didn't. I was just thinking.
So yeah, you can make that void. Or if it's got to be an int for some reason, but you don't care what the value is, you can just return 0. There is an exit function, but it's a little bit heavy-handed, and I think exit forces you to give a return value anyway. So you'd be better off just, you know, returning 0 or whatever number you like. All right, and yeah, we'll talk about the header in a second, but yes, it's good practice to put the prototypes in a separate file, which will be called an include file. I wouldn't do an abort. That's probably even more heavy-handed than an exit, and it might circumvent, you know, things like the assess program. Return is a pretty safe way to get out of your main program. All right, so other functions. You want a function named predict in a file called predict.c. This is the one that does the math to figure out if you're playing between low and high, how many guesses is it going to take. And so this returns an integer, which is the maximum number of guesses. And then you want a file called getanswer.c, right, with an uppercase A. But I can't highlight it. And that should contain a function called getanswer. Takes no arguments, returns a character. And the whole purpose of this function is to wait for the user to type either an H, an L, or a C, and then tell you what they typed. So this is your while loop, which says, you know, print a message, do an fgets, see if they typed, you know, exactly H, L, or C. If they did, return the corresponding character. Otherwise, you know, print a message like, you know, please enter H, L, or C, and try again. And so that does all of that looping and checking of their input and so on and so forth. And then you have a main program, main.c, which is your main game. And so you can write additional functions, put them in additional files, that's totally fine, right? And in fact, it's encouraged. So if you really wanted to break this into pieces, what might you do? You might make a function for parsing the command line arguments to see how many arguments you have, and you know, are they all integers, and is the first one smaller than the second if there's two of them, and does all the work needed to figure out, hey, let's play the game between this and that, right? You might call that setup or something. So now your main program is pretty simple, right? It calls, you know, setup to figure out what the game is. It calls intro to print a welcome message. It calls predict to decide how many guesses it's going to take, and it tells the user that. And asks the user to think of a number, hit enter, so do an fgets to wait for that. And then go into a loop, right? Make a guess, we'll talk about that in a minute. Call getanswer to see if it's high, low, or correct. If this returns a C, the game is over. If it returns an H, make an adjustment to your high, low. We'll talk about that. If it's an L, make an adjustment, go back to the top. And just loop until the game is over. The game is over when the user says your guess is correct, or when your algorithm says someone cheated. So if you break this into pieces, your main program is potentially really, really small. It's a handful of lines calling all these other things, but these other things do, all the hard work. So you also want a main.h, and every function that you have to prototype, for example, in the beginning of main, we need to say void intro paren semicolon. To tell main, hey, there's a function called intro. It takes no arguments, returns nothing. Put that prototype in a main.h file. Put this prototype and this prototype in that same main.h. And then in the beginning of your main program, you can just say include main.h. And it pulls in all those prototypes. And we're going to see specific examples of this on Monday, right? Where we'll go through a different program, but something that uses the same steps.
So that .h file only has to have the prototypes?
Exactly, yeah.
Okay.
And yeah, main.h, you can put in all the prototypes, even if you have something that doesn't get used in that particular file. It doesn't hurt to prototype it. And yeah, if you put in additional functions, if you make a function like, setup, put that prototype in main.h also.
And as long as the files, or the function files, are in the same directory, right, it should still be able to use all those functions?
That's correct.
Okay.
Alright, and for this assignment, I'm going to want a README file. And the README is a readme.md, uppercase readme, lowercase md. And in here, put in your name, the class name, the date, a description in your own words of what the program does, whatever other documentation you want, kind of outside of your code itself. So that's the README. If someone went to Git and pulled down your code and said, what is this, right? They could look at that and see, oh, it's a high-low game, That's cool. Alright, so you're going to have all these parts and pieces. You're going to have an intro.c, a predict.c, getAnswer.c, other functions you write.c, main.c, main.h. Those all have to get compiled together to make your executable, which is just called main. And there's a lot of ways to do that. So starting Monday, we'll talk about what are called makefiles. And as I've mentioned, a makefile is a way to basically describe a recipe which says, hey, given these parts and pieces, how do we build an executable? And so you're going to need a makefile as part of this assignment. And we'll go through examples of this on Monday. We'll talk about the details. You'll see templates for makefiles you can use. And it's really not a big deal to do a makefile, right? Unless, your assignment's due in 20 minutes and you've never looked at this. But if you start this ahead of time, early next week, it's really not too bad, right? It's use a template and just change the specifics. Yeah, I upped my game on the formatting of this assignment, so it is more serious. All right, so submission through Git as usual. So make a subdirectory PA3 under 224, and make sure your directory contains the README, the makefile, and all the source files needed to build the executable. And you can do things like, make your repo, upload it to Git, go into a different area on your machine, clone the repository, hop into PA3 and say make. And it should build an executable and then run your tests, right? So you should absolutely be able to tell ahead of time whether or not, you've submitted everything and everything you've submitted compiles, and the result of compiling is your program that you expect. There should be no surprises for you. All right, we'll do makefiles on Monday because we won't have time today, probably. All right, and then grading. So you've got a full grading rubric here. All right, and the thing to note here is, again, it's possible you could make a game that plays perfectly but doesn't get you a lot of points. It's also possible you could submit a directory that has no code in it but still gets you like 30 points, okay, but doesn't actually play the game. So pay attention to the grading rubric, right? Come back to this as you're working. So executable has to be named main. That's 5 points. If you just run your program with no arguments, it plays from 0 to 100. That's 5 points. If you can specify one argument or two arguments correctly, that's worth 5 and 7 points respectively. If it does perfect error handling with the command line arguments, that's worth 7 points. Meaning any of these situations and any other ones that we haven't tried where you put in funny things, too many arguments, non-integers, haha, things like that, any of those it should detect and it should throw an error. If it works for every possible error case that I come up with, you get 7 points. If it misses any of them, then you don't get the 7 points. Prints a greeting in the beginning and mentions what your range of numbers is, that's 2 points. Waits for the user to think of a number and hits enter in the beginning, that's 3 points. So don't just jump in and say, is it 50? Is it 50? Did you think of 50? Give them a minute to think of it and hit enter. Makes the correct prediction on the number of guesses, that's 5 points. For each guess that it makes, print out the number of that guess, right? Guess 1, guess 2, guess 3, and so on, followed by the guess. That's worth 5 points. Using the correct algorithm that we're going to go over next for making the guess, that's 15. Responds correctly if you say C for correct, prints an error, and lets you retry if you type anything else, that's worth 6. Detects cheating is worth 10. Program is split into the pieces as required above is 15. And the makefile is satisfactory for all requirements, that's worth 10. Alright, and that should add up to 100. Alright, so let's talk about the algorithm. I'm done with my lunch, I can turn my camera on. So what's the idea here? You're trying to guess somebody's number between, let's say, 0 and 100. There's 101 numbers in there, and if you just start making guesses, it could take you a long time. If you're really unlucky, it could take you 101 guesses, or if they keep, changing the number to be something different. So how do we do this efficiently? Make your first guess something right in the middle. So your first guess is going to be exactly halfway between the low and high, or, if it's not an integer, the closest integer to something in between low and high. So we would say, is your number 50? Okay, if it happens to be 50 they were thinking of, great, we're done, it only took one guess. But assuming, for example, that 50 is too low, we know that 50 is not the right answer, but we also know the answer can't be 49 or 48 or 42 or 30 or 20 or 10 or 0. In other words, all of these numbers are now removed from contention. If 50 is too low, we've got a new game to play, which is, hey, this person is thinking of a number between 51 and 100. So yeah, the algorithm takes the first guess by dividing the range in half. And once we do that, now we have a smaller range, right? We only have 50 numbers in here. Let's do the same thing. Let's just pick a number in the middle. So this would come out to probably 75, right? So the number exactly in the middle is 75.5, right? So we'll just go with 75. And same thing, if this turns out to be high, we can eliminate 75 and any number bigger than that. And now we've got an even simpler game to play. This person's thinking of a number between 51 and 74. Right? Well, there's only 25 numbers in there. So with two guesses, we've pared the problem down from 101 possibilities to about 50 possibilities to about 25 possibilities.
Is this just using modular arithmetic? Instead of mod 2?
More or less, it's related to that, but it's not exactly modular arithmetic. Although there's an interesting way we could analyze this, looking at things in binary. But this is an example of an algorithm type called divide and conquer, and there's a whole class of algorithms out there that fall into this category. And it's called divide and conquer because what are we doing? We're taking a problem and we're changing it into a simpler problem. Now we have to use up one of our guesses to do that, but by using one guess, we've changed it to a problem half the size. And with a second guess, we can change it to a problem half the size of that, a quarter the size of the original. And if we keep doing this, we will very quickly get down to where we're trying to guess a number between, say 63 and 63. And there's only one number in between there, right? 63. And unless someone's cheating, we're guaranteed that's the number. So once we can get this down to a range of just one number, we're done. We know what the number is. So if we take a number n and we divide it by 2 repeatedly until we get down to 1, it ends up taking approximately the log base 2 of n such divisions. And this is great because 100 numbers, we can do that in 7 steps. 1,000 we can do in 10. 1,000,000 we can do in 20. 1 billion we can do in 30. 1 trillion we can do in 40. So from 1,000 to 1,000,000, that's 1,000 times more possible answers, but it's only going to take us 10 more guesses. From 1,000 to 1 trillion, right, that's 1 billion times more possible numbers they could be thinking of. It only takes us an extra 30 guesses. So this is a really nice behavior for an algorithm, this logarithmic behavior. And this is the behavior we're going to see in winter in CSE222 when we talk about binary search trees. And playing high-low, is a kid's game, but it's really what computers do. Computers are always searching for things. If you have a database, all right, cool, have a good one. If you have a database and you're searching for information in there, it's a search problem. And if your database has 1 trillion things in it, do you want to search 1 trillion things one by one to try to find something? Probably not. So if we can do something like play high-low, we might be able to find this item in 40 operations. So this will pop up a lot in computer science in general, and we'll talk about it a lot in winter.
But that requires a well-ordered database.
It requires a well-ordered database, yes. All right. So how do we do this? This is all spelled out in the write-up, but let's look at the section on algorithm. Right. Basically, we need to keep track of 2 things. We need to always know what's the low and high range that somebody could be thinking of a number in. So we're going to start off just the default game, low is 0, high is 100. They're thinking of a number somewhere between there, inclusive. And we make a guess, which is the average. So high plus low over 2. Right, so that's right here. Make your guess equal to low plus high over 2. And do this as integers. So if this is, 5 and 10, high plus low is 15 divided by 2. Just do the integer math. Don't try to round it or anything like that. It'll come down to a 7. That'll work out great. And yeah, it should round down. All right, so once we have a guess, ask if that guess is high, low, or correct. Okay, if too high, then we want to change our, if the guess is too high, we want to change our high variable to be guess minus 1. If instead the guess was too low, then we want to set our low variable to be guess plus 1. So we start off with a high and low range, we make a guess, we ask them if it's high, low, or correct, and if it's too high or low, we're going to adjust one of these variables. And then we're just going to go back and make another guess. And after not too many tries, that should bring us down to the person's number. So if the guess was too high, change high to guess minus 1. If the guess was too low, change low to guess plus 1. The one trick is, each time that you change high or low, do a check, see if low is bigger than high. And if it is, you can say, hey, the person was cheating. So down here, I would do my cheat check. All right, and this will work. This is guaranteed to work. If you do it exactly like this, it will work perfectly. If you do it slightly differently from this, it probably will not work, right? You're welcome to explore that, and if you can find a different way to do it that makes sense, go for it, okay? But if you decide you're just going to set high equal to guess instead of guess minus 1, don't be surprised if it doesn't work in all cases, right? It's an algorithm, and I encourage you to think about this and convince yourself that this makes sense. And if you find some other way that makes sense to you that's different from this, you can go ahead and use that, okay? But if you're trying to code this algorithm and you decide to check for cheating up here instead of down here or something, right? It may not work. And you're welcome to use this algorithm as is, right? But of course you can also dig into it. All right, that's really all we need other than this question of predicting how many guesses it's going to take. We can talk about that on Monday, but it's really just a formula. But we'll talk about how to get logarithms in C and how to turn this into an integer. And then you're basically good to go. All right, so you can catch the end of the early morning's lecture if you want to pick up those details, and my suggestions on how to get started on this are at the end of the 10 o'clock lecture. But other than that, I will see you tomorrow at 11 o'clock for your midterm. Please try to show up on time, because having time is good. So I'll see you at 11 o'clock tomorrow. Send me an attendance note on the way out, and have a good afternoon.
Goodbye.
All right, have a good one.